But RDT 2.0 has a fatal flaw. Yeah. If data can be corrupted, therefore a receiver needs to send ACK and NACK to provide feedback to the sender. The ACK and NACK coming from the receiver to the sender, those packets can also be corrupted. So what if that feedback packet is corrupted? Then sender will not know whether it's really an ACK or a NACK. So, so should the sender retransmit, or should the sender say, okay, I'm just gonna wait for another call from above? Dilemma. So what do we do with this? If you think a little bit further or recall back, didn't we have the same situation, right? So when data is corrupted, we ask the other end to send feedback. So perhaps we could ask the sender of the data to send feedback so that the receiver will know whether the ACK or NACK is corrupted, therefore retransmit the ACK or retransmit the NACK. Yeah. So how did we deal with the corrupted data? We do the checksum, right? At the receiver. Well, actually, we do the checksum at the sender, adding that into the packet, and receiver check it again. Now, if it's not a match, we send NACK. If it's a match, we send ACK. So this is receiver side action. And therefore, at the sender side, we could retransmit data. So perhaps we'll do this, right? So ACK, NACK corrupted. There's potential. So why don't we do checksum, okay, on the ACK, NACK? So receiver there adds checksum for the ACK, NACK. Sender there checks if the checksum matches. And sender, upon seeing a mismatch, sends a NACK for the ACK or NACK. If it's a match, sends an ACK for the ACK or NACK. Therefore, data receiver there can retransmit the ACK and NACK. Oh, makes sense. But if you think a little bit further, how do we ensure that the ACK NACK for the ACK NACK is going to arrive back at the receiver, right? What if these guys are corrupted and therefore the receiver will not be able to tell whether the former ACK NACK being sent is corrupted or not? Exactly. What happens if the ACK NACK of the ACK NACK gets corrupted? Okay, so you have circular dependency there, and the problem never gets solved. So alternative thinking coming next. The new thinking to address the circular dependency we saw earlier is this. The sender, okay, will just not figure it out, okay, whether it's ACK or NACK being corrupted, okay? So sender will just pretend to be dumb and not trying to ask for a clear answer. Sender here instead retransmit the data that's already sent to the receiver. Would that work? If the corrupted ACK NACK is a NACK, then hey, this addressed the issue, isn't it? If the corrupted feedback is an ACK, then this actually creates duplicates. So the receiver side, in case it being an ACK feedback being corrupted, might have duplicate data. So this is actually not good because at the receiver side, it's going to receive segments one after another. And it's just going to reassemble everything and then pass it up to the receiving process. If that's the case, you might see typos, duplicated sentences, duplicated phrases here, there in a document, or sometimes duplicated pictures or partial pictures. Okay. So in RDT 2.1, to really seriously addressing the issue, we need to add a sequence number to the packet sent so that the receiver side can check the sequence number and see if the packet that has already been received earlier matches the sequence number that I'm receiving now, the receiver is receiving now. If they match, then that is very likely a duplicate from the sender, okay? And the corrupted feedback is an ACK. Okay. So, entirely in RDT 2.0, sender will just retransmit the current packet in case the feedback is corrupted. But in the packet, it's going to carry a sequence number that will allow the receiver to tell whether this is a duplicate or not. In case the receiver detects it's a duplicate, it would scar the duplicated packet. And this is RDT 2.1. And there's one more thing we need to talk about. That tells a little bit about the sequence number requirement here. Think a little bit more. RDT 2.0, RDT 2.1. The sender behaves this way. After sending one data packet, it's going to stop and wait for feedback until everything is cleared. Then it will go back to send data again. So sender sends one packet and it's going to wait for feedback until everything is cleared and move on. So you see, if the receiver during the phase in stop and wait state receiving two packets carrying the same sequence number, then that must be a duplicate due to a corrupted ACK, isn't it? Yeah, so sequence number in such form of reliable data transfer is very simple. It needs only one bit, two numbers, 0 and 1, to tell whether it's a duplicate apart from a new packet. Now, judging from the description, it sounded somewhat easy, not that complicated. But if we look at the finite state machine, it looks somewhat complicated. And you know what? This is only the sender side of the FSM. We have not yet looked at the receiver side, all right? So this is the sender side of RDT 2.1, which is the version of reliable data transfer that handles corrupted ACK coming back from the receiver. Okay. Now, the easiest way to look at the finite state machine here is by drawing a line separating the two mirror parts. So if you look at the upper right part of it, this looks like the wait for call from above state in RDT 2.0 sender, isn't it? And wait for ACK and NAC, this looks like the waiting for feedback state in RDT 2.0 sender. If you go down further, this other half, it's actually very similar. Wait for call from above, and then wait for ACK/NAC. Okay, the only difference is this. Wait for call for packet 0 from above versus wait for call for packet 1 from above. We just talked about the sequence number required to separate two packets one after another. From a duplicate, a retransmission of an existing packet, isn't it? So having 0 and 1 is a way to tell duplicate packet apart from a fresh packet. So we do need to have the separation here in RDT 2.1 sender. And as a result, when we get a call from above, so application calls RDT send data, will then trigger these actions to occur. So we'll be making packets, taking data, and we do the checksum, right? So this is in order for the receiver to check and see if the receiver sends ACK or NAC. The new thing we add here is to add sequence number to the packet we're creating. So the send packet here now contains not just data, not just checksum, but also a sequence number. And as usual, we send it out through the network layer. So we call at the transport layer called UDT send. Now, the second thing that is a bit unusual is also this. Hey, the feedback state, wait for feedback state, you see, wow, the condition looks all complicated. Yeah, particularly if you see, we're now checking first whether the feedback we receive is corrupted or not, whether it's actually intact or not. So this is the case when it's corrupted. This is the case when it's not corrupted. So if we receive a packet from the network layer, receive a feedback packet from the network layer, and we check that it's not corrupted, everything is fine. And that packet is a positive feedback. That means what? Transmission of packet 0, perfect. So we do nothing and then we move on to wait for call from above again. All right, so this transition here is straightforward. Now, what is a little bit unstraightforward is this transition. So this is the transition that we come back to wait for feedback again. Okay, so these are the complicated cases. You see here, if the ACK or NAC coming back is corrupted, what do we do in RDT 2.1? We'll just retransmit the packet that's sent once earlier, isn't it? So if it's corrupted, simply send it again. So the send packet here is not actually being reassigned. So it will be the packet we have sent earlier. So it will be carrying sequence number 0. There's another condition. If the packet is not corrupted, but it is a negative acknowledgement, then it's just like in RDT 2.0, we retransmit. All right, so this transition here gets, doubled. It's checking two conditions. If it's not corrupted, a negative acknowledgement, retransmit. If it's corrupted, also retransmit. So we have two conditions that actually ended up doing the same thing, just retransmit. All right. And so that is the sender side of RDT 2.1, and we'll just not cover the rest of it because it's pretty much the mirror. Okay, the only difference is just that handling data packet 0 versus data packet 1.